Hello, sir. So today in this lecture, we'll be learning about the timers and counters in 8051, as well as the bit structure of the special function registers like T-mode as well as T-count registers. Uh, so before beginning with that, just check out like what is meant by what timers and counters, and what is the need of timers and counters in microcontrollers. Many microcontroller applications require the counting of external events such as the frequency of a pulse train or the generation of precise time delays between the two computer actions. And both of these tasks can be accomplished by using the software techniques. But software loops for counting or keeping up the time or monitoring the time or having the time delay. So they kill the processor time. That means the processor time is wasted. Okay, so that instead of killing the processor time, okay, the processor can be used to perform some other useful work. Okay, means the burden of your processor can be relieved. Okay, so for that reason, there are two 16-bit up counters named as T0 and T1. They are provided in the which are provided for the general use of the programmer, and each counter can be programmed to count the internal clock pulses. Okay, so if it is counting the internal clock pulse means on each clock pulse the counter will be incremented by one. So if the counter is incremented with the help of your internal clock pulse, then we call it as a timer. Or the same circuit or your timer, it can be programmed to count the external pulses. So if the timer is counting the external pulses, then it is called as a counter. Okay, and specifically the timers and counters, they are generally used for, okay, to have the time reference or creating the time delays between the occurrence of two events, or whenever you want to execute or have a time gap between the execution of one instruction and the another instruction. Okay, in that case you can have a delay between, right? The waveform properties measurement, periodic interrupt generation, and waveform generation. So timers in 8051, okay, either they can be used as timers, counters, or also they can be used as a baud rate generator. Okay, so basically if you take it as a baud rate, okay, that comes in a serial communication, that is the number of bits which are transmitted per second. Okay, the data transmission rate, how many bits are transmitted per second. Okay, so that we call it as a baud rate. Okay, so either you can use it as a timer, or you can use it as a count, or they can be used as a baud rate generator. So timers always they count up irrespective whether it is used as a timer, counter, or baud rate generator. So always the timer is incremented by your microcontroller. So the time taken to count one digit up is based on the master clock frequency or the operating frequency of the microcontroller. So if you say, for example, if the master clock frequency is 12 megahertz, okay, then the timer clock frequency, okay, the frequency which is applied to the timer, that is the master clock frequency divided by 12. So the frequency for your timer circuit will be 1 megahertz. Okay, and the timer clock period will be 1 microsecond. So this indicates that to increment the count by 1, the microcontroller will require 1 microsecond. So timers in 8051. Okay, so the 8051 has two 16-bit timers labeled as T0 and T1, that is your timer 0 and timer 1, which can be used to generate accurate time delays, or they can be used as an event counter. So these timers are accessed as two 8-bit registers. Okay, TL0, TH0, TL1, and TH1. Okay, so whatever the registers, instead of the one we say timer 0 and timer 1, okay, that is T0 and T1, which are having two 16-bit registers or to hold the count value. So these two 16-bit registers, they can be considered as a combination of two 8-bit registers, okay, TH and TL, because the 8051 microcontroller is having a 8-bit architecture. So coming to a timer 0. So timer 0 is a 16-bit register and can be treated as two 8-bit registers, TL0 and TH0. And these registers, they can be accessed similar to any other registers like your register A or B or R1, R2, R3, R4, R5, right? So if you want to copy any number or immediate, you want to load a value Okay, then by using the instructions like move TL0, for example, 07. Okay, that 07 will be copied into the 8 bit of your timer 0. Or so if you want to copy the content of timer registers into any of your general purpose registers, like for example R5, you can be done with the help of your instruction like move R5 comma TH0, which saves higher byte of your timer 0, that is TH0, the content of your TH0 into register R5. Then you have a timer 1. So timer 1 is also a 16-bit register and can be treated as two 8-bit registers TL1 and TH1, and these registers can be accessed similar to any other registers, right? And these two timers, timer 0 and timer 1, okay, they share two special function registers, that is your TMOD timer mode register and TCON timer control register. Okay, and these two registers, TMOD and TCON, mode register and control register, they control the timer, and each timer also has two SFRs dedicated for them for itself. Okay, so you have two registers which are dedicated purely for your timer 0 and timer 1, and these two registers TL0 and TH0, they hold the 16-bit value, the initial value for your timer 0, and TH1 and TL1, okay, they hold the initial value or the count value for your timer 1. Okay, they are independent. Whereas your TMOD and TCON, okay, these two registers are shared by both the timers, timer 0 and timer 1. Okay, so